Hey guys, all wrapped up today. So today's video is the third and final part of my duct design training videos, and I think you're really going to love this information. I had a lot of fun putting it together for you, and I think you're really going to like this this first segment because it's pretty cool how you can do this. And I forgot about it, the old trash bag trick that I did. Probably 25 years ago. So check it out, guys. Glad to put this together for you. Hey guys, how did we get to the point here where we're talking about trash bags as they pertain to HVAC? How did we get here? So this is the culmination of my 3 videos, and I wanted to put it at the front of this video so it keeps you intrigued on how we got here. If you don't have a flow hood, this is a cool way to check the CFM of a register. You tape your trash bag over your register opening, okay? So a standard, like a Husky construction cleanup bag, is 42 gallons, okay? 42 gallons is equivalent to 5.61 cubic feet, okay? So what you do, because flow hoods are expensive, you don't spend $4,000 on a flow hood, do you? When we can do it this way. So let's say the bag fills up in 5 seconds, okay? That's equal to 1/12 of a minute, or whatever this number may be, okay? So what you do is you take 60, which is a full minute, and divide it by X, however long it takes to fill up that 42-gallon bag, and you're going to times that by 5.61. That's 1 cubic foot, okay? So let's say it does take you 5 seconds. So that's 60 divided by 5 gives you 12. You times that by your 5.61, that's your cubic feet per minute, and that gives you 67.32 CFM. You can do this with any size bag. It's easier with a big one because it's going to fill up real quick. So what you do is have your helper go turn the thermostat on to cooling, have your bag taped over your register, and do this. Time how long it takes to fill up the bag. Once it's full, it's going to pop your tape loose because it's pressurized, right? So do it until your bag's pressurized, and then time it. And this number will change. So use this formula, however long it takes to fill up that bag, put in where that X is. So it'll be 60 divided by whatever times 5.61. That will give you your CFM. And that's on a 42 gallon. You'll need to convert if you have a different size trash bag. You'll need to convert this from gallons to cubic feet, this number will change based on how big your trash bag is. Just punch it in. They got formulas online. 12 gallon would obviously be different, etc. So thought you guys would find that cool. Nobody wants to buy a flow hood. I sure as heck don't. If I need to dial in somebody's CFM, this is really easy to do. You just tape down a plastic bag over your register. So thought you guys would think that's cool. Let's get on to the final duct design video. Okay guys, welcome to part 3, the final part to this duct design class that I put together for you. So here's where we're at. So if you watch the previous videos, we figured out how to get our friction rate. This is the value that you're going to put on your ductulator, okay? 0.07, I'm just choosing that for the sake of the video. This number is going to vary. It could be anywhere from 0.04, 0.05 to 0.1, depending on how your duct system's designed and what static pressure you're going to use, and what your total equivalent length of your duct's going to be. So this is going to be a 3-ton, 1200 CFM system, okay? I'm going to show you how we come up with all these duct sizes and how we lay this out. So right here is our air handler, okay? 1200 CFM air handler, whether it be a gas furnace or a standard air handler, electric furnace, heat pump. So how do we determine these sizes of the duct? Okay, so what you're going to want to do is put your CFM on your first section of the duct before you have any of your supply takeoffs off. Okay, so that's going to be 1200. So what gives us 1200? Well, you put on your slide rule 0.07 friction rate, and at 1200 CFM that gives us 16-inch hard pipe or 20-inch flex. So this section is going to be that size, okay? So then what you do is, you know, obviously every system is going to be different. So let's say we have two takeoffs here. One of them needs 100 CFM, one of them needs 40. Now this is all based off our heat loss analysis and converting those BTUs to CFM. So this is going to vary quite a bit from system to system. I just did these numbers randomly to equal 1200 CFM. Obviously, sometimes the rooms each need a little bit different, so you always want to put dampers in each run too, because you're going to need to dial these in. So anyway, so you got 1200 CFM, that would be a 16-inch hard pipe or 20-inch flex. Then you would take these CFMs off, which would be 140. Okay, then you can put a reducer here and reduce it down if you can. So at 1060 CFM, because remember we lost 140, you're going to be at 1060, 1200 minus your 140 is your 1060, and then so that's going to be 16-inch hard pipe or 18-inch flex. Okay, then let's say we have another two takeoffs that takes another 180 CFM off. Okay, so you're going to reduce it again, and this time you have 880. Oh, so the 1060 is 16-inch pipe or 18-inch flex, just based off of this value, okay, your friction rate. Then you continue to taper down, so 880 would still be 16-inch or 18-inch flex. I just put the quotations because it'll be the same. Two more takeoffs gets us down to 790. That would be 14-inch or hard pipe or 18-inch flex. Two more come off. I'm going over this real quick because it's kind of monotonous once you get past the first one. Then you're down to, because you're taking that 350 off of that, so you're down to 440. That gives you 12-inch hard pipe or 14-inch flex. And then your last two, obviously, you have 300 CFM left because you have 200 and 100, would be 10-inch hard pipe or 12-inch flex. When you're doing this, it's very important to reduce it when you need to, because that maintains your velocity that you need, okay? If you don't do that, you're not going to maintain the velocity, and the air's coming out is not going to be the proper CFM. So you got to maintain the velocity. Also, you don't want to taper it too soon, or you have too much velocity and you end up with a duct system that's too noisy. So you don't want that either. One thing I want to note, when you take your last run off of your trunk line, okay, this is what's called a reducing plenum duct system, which is pretty common in most new builds. So that's kind of what we're focusing on here. You want to make sure that after your last run, you have 18 inches of duct past your last run. That's so you can build up back pressure. So what's going to happen is the air is going to fill everything, it's going to hit this, and then it's going to pressurize, and it's going to push the air out through the ducts. As long as you design it right, it's going to push them out properly. You're going to have a damper on every run, and then you dial in each CFM. So how do we determine these branch run CFMs? Same concept, 0.07 friction rate. So based on that friction rate, 200 CFM is going to be 9-inch hard pipe or 10-inch flex, okay? 100 CFM is going to be 7-inch hard pipe or 8-inch flex. Let's go to a different size. 150 CFMs, 8-inch hard pipe, 9-inch flex. Now, one thing that you want to do when you're building these duct systems too is some of the best takeoffs of these are the 45-degree cone saddles. So they're kind of a fitting that looks like this. It's got a little bit of a cone there, and then it shoots off at a 45-degree with your round throat on it. That's going to give you your best flow into each run. I strongly recommend doing that when you're doing a round system. They make a flat, like let's say if this was rectangular duct, they make a flat airtight takeoff that works good, but I think they just make straight ones. What you want to do in that instance then is put a 45-degree elbow right off, and that'll help your airflow. What else here? So obviously you want to seal everything 100%, and you want to insulate it for whatever your jurisdiction tells you to. So let me show you something else here. So on our return, how do we come up with this? So same concept, 1200 CFM is going to be 16-inch hard pipe or 20-inch flex. There's no getting around that. That's the two sizes based off this friction rate that you have to have, okay? So how do we determine our grill size? It's 20 by 25 on a 3-ton system. Let me show you that. Okay guys, we're over here at our little cheat sheet for doing your return grill area. So the formula is 1200, which is our CFM. That would be a 3-ton system, right? Divided by 350. Okay, this is a formula. So it's X, which is your CFM, divided by 350 will give you a number, a different number each time based on what CFM we're looking for. That converts to 3.43. Then what you do is you take that 3.43 and you times it by 144. And that gives it, and the reason you're doing that is this is your square footage of your grill. And we need to convert it to inches, so you know, because they don't do it by feet, they do it by inches. So this converts it to inches by timesing it by 144. So 144 times 343 equals 494. That's 500 square inches. Okay, so we know that 20 times 25 is 500 square inches, so that would be a perfect size. You could come up with any size of grill. You know, let's say you got studs that are 16 on center, so you go 16 by, I don't know, 30 something, 32 would get you there. And that would give you either 500 or 494 that you need. You know, obviously they don't, you'd want to do something that's 500 because 494 is a weird size. And then on all of these, this formula is basing it on the fact that you have a 70% grill area. You know, you don't have a full 20 by 25, but it already takes this off in that formula. So check with your grill manufacturers and make sure that you have that free space area in that grill. A lot of guys will put those honeycomb return grills in, which is a lot better. They have a higher percentage of a grill area than a standard stamped return grill, like what are they, the 1050s by Shoemaker. So that's the formula you want, guys, for sizing your return grills. You know, this is the CFM of your system. All these other numbers are going to stay the same, okay? You're going to divide by 350 and then times that value by 144, and that'll give you your square inches, and then you can size your grill based off that. But also look at your manufacturer's specs and make sure that you have at least a 70% grill area. If not, you'll have to adjust this number, okay? You want to upsize it a little bit, you know, based on this percentage. So hope that makes sense to you. Let's get back to the duct system. All right, guys, so let's summarize this real quick. So you always want to start out with your total system CFM and reduce your plenum. You know, everyone's going to be a little bit different. Some systems you might reduce it after 4. Just depends what makes sense for changing your duct sizes. As you can see, after this first takeoff here, the hard pipe size doesn't change. So you're just going to do this. You know, there'll be no reduction here. That's why it's important to maintaining velocity. You're going to have dampers. That's going to maintain your feet per minute and maintain your CFMs. So do a nice taper down to make sure that you get that air to your last runs here, because remember, this number here is based off your longest run, okay? You want to make sure that there's enough air left to get your CFMs to your furthest, your run that has the most total equivalent length. So let me know if all this makes sense to you. I went over the grill sizing. You know, most guys are going to run flex up through an attic, so always make sure you're changing your size of pipe if you're going to do flex. This whole thing could be flex too. I'm not against flex, but just know that you need to pull it really tight in order for these numbers in order for that size of flex to work. You know, there's going to be a lot more compression with flex. You want to make sure you avoid sharp turns with it. In a perfect world, we do every system in all hard pipe, which I strongly recommend. In commercial, you know, they don't allow you to go more than 5 feet of flex. So I think residential should adopt that too, hard pipe and then just a little flex at the end, just for sound attenuation. So that's basically it, guys. If you have any questions how we got to this point, you know, you have all 3 videos. You should be able to design a duct system from scratch now, just with a pen and paper. You shouldn't need any programs. That's how I do it. Sometimes, you know, it's faster to use the programs, obviously, but I learned how to do it this way, and I'm kind of proud that I can do that, and you know, helps keep our mind sharp too. So thanks for watching, guys. If you got any questions, let me know.